Hello and welcome. Today we are going to be looking at number 5 on homework 8. Well, it's our current homework, the homework for projectile motion. And the question says, a ball is thrown upward and returns to the thrower's hand 2.47 seconds later. A second ball is thrown at an angle of 39 degrees. At what speed must the second ball be thrown to reach the same height as the first ball? Okay, and so we've got one ball that is thrown upwards like this and reaches a certain height, and then we have a second ball which is thrown at an angle, and we want to see how hard does the second ball have to be thrown in order to reach the same height as this one. And it turns out that when a ball is thrown diagonally like this, it is actually the y component of the velocity that determines how high it goes. And so what we need to do is we need to figure out what is the initial velocity for ball number 1, and we need to set that equal to the y component of ball number 2. All right, and so I'll walk you through that process, but that is what we're going to be doing. We're going to be finding out what is the velocity initially for ball number 1, and then we're going to be setting that equal to the y component of the velocity for ball number 2. All right, so let's go ahead and get started. Let's see, so we're going to write our givens here. Let's see, we don't know what the initial velocity is. That's what we're actually looking for. Since the ball goes up and comes back to the same height, delta y is going to be 0. Actually, let's cancel that because I'm not going to solve it at the returning point. I'm actually going to solve it at the top of its flight. So that I can set VF equal to 0. So the time, which is 2.47 seconds, I'm going to split in half because I'm going to solve this at the top of its flight. I'm going to solve it, if we look at it as going up and coming back, I'm going to solve it at this point right here at the peak of its flight, where V is 0 meters per second. And so that's going to give me what I want, and I'm going to solve it there. That means I need to have t 1/2, which is going to be 1.235 seconds when I split time in half. All right, and I'm going to say that VF equals 0 meters per second. So with all that in mind, I'm going to come over here and I'm going to say, okay, VF equals VI plus AT. I didn't write A down, but hopefully you know and remember that the acceleration due to gravity is 9.81 meters per second squared. 9.81 meters per second squared for this problem. So I'm going to say VF is 0, and that's equal to VI minus 9.81 times 1.235. And then I'll have that 0 is equal to VI minus, and I'll do the multiplication there, and that's going to come out to be 12.1154, and I'm going to keep all the decimals since I'm working on my homework, meters per second, which means that when I swing that across, VI will be equal to 12.1154 meters per second. Okay, so there's the first part of our question that we need to know, and that is the fact that this ball is thrown with an initial velocity of 12.1154 meters per second. Of course, your number will vary, but that's my number. So what I need to do now, and I'm going to switch colors for the second part of the problem, is I need to say, hey, if I've got a second ball that is thrown at an angle, what is its velocity going to have to be so that this component of it is equal to 12.1154 meters per second. Okay, so we're not looking for the x component. Of course, the x component is there, but we're only trying to find the hypotenuse from the y component. Now, this is slightly different from what we've done before. Previously, we've always known the hypotenuse and we've looked for the components. Now we know the component and we're going to look for the hypotenuse, but it's not much harder, just a little different. So knowing that I'm looking for my hypotenuse and that I have my opposite side from my angle theta, I'm going to choose the sine function. So sine equals opposite divided by hypotenuse. And in this case, we're actually solving for hypotenuse. So sine theta equals opposite divided by hypotenuse. So what I'm going to do is multiply both sides by h, which will pull an h over here, and then divide both sides by sine theta. So h sine theta equals O, and then divide both sides by sine theta. So h is equal to opposite divided by sine theta. At this point, it's just a matter of putting in values. So hypotenuse, which is going to be my velocity, is going to be equal to my opposite side, which is 12.1154, divided by sine theta. And I'm just going to write that as sine 39. When I do the math on that, I get that the velocity ends up being 19.2515 meters per second. And so that is actually then going to be my solution for my question number 5. All right, so that is how to work through question number 5. I hope that was helpful. Again, remember that the main point is that we were working so that this VI of the first ball was equal to the y component of the second ball, because it's the y component that actually determines the height and the time in the air for the ball. All right, have a good day.